If you make components for your products from stainless steel, you know the issues with corrosion, scratches, and denting. And if you use fiberglass, you are aware of how it tends to crack, splinter, or shatter on impacts. Not to mention the stricter environmental regulations on VOCs. Thinking about injection molding, be prepared for the sticker shock for tooling. That's what you need to convert your metal and fiberglass parts to thermoformed plastic.
This part was metal. This part was converted from metal to plastic. This is a pressure formed part. This is the front of an ice machine. What we have done is we've pulled this into a female tool to get all of this definition. You see the part is smooth here and it's textured here. Then we flip it over and we cut these ribs open on our CNC machine. We actually go in and we weld this bracket on each side of this part so that when this fits on the ice machine, it can just hang on the front of the ice machine. We do a lot of conversions because of the cost of metal, the cost of stainless steel, also the cost of finishing metal these days. This part was extruded gray, formed gray, and it's ready to go. All we need to do is put a pad print or a silk screen on the front of it to finish the decoration. This part's ready to go. No, there are no tariffs on plastic. All the plastic we use is made in the United States. In fact, in this plant, a substantial amount of the plastic we make is made right here in Atlanta.
The biggest benefit of thermoforming over injection molding is time to market. We can really get your product out the door quicker. From time to the prototyping, it's only 2 weeks we can have something out the door.
If you're having problems with fiberglass, if the lead times are too long, if the production times are too long, if the price is too much, we can give you a part as good or better than the fiberglass for less money, much quicker. The part I'm showing you is out of TPO. It's a perfect replacement for fiberglass. It's hard, it's tough, it's durable out in the sun. You could beat this with a sledgehammer.
Thermoforming is the process of forming a plastic sheet into a three-dimensional shape using heat and vacuum as the process. It's formed either over a mold or into a mold. This is a 12-foot ABS drain pan. And these are used on refrigerated display cases. This replaced sheet metal pans that rusted, corroded, and they also weren't NSF compliant. It's guaranteed not to leak because it's one solid piece. Here at C&K, we can make very large parts. This is a pretty good sized part, but we can make a 14-foot part if you need it. This part is made out of ABS. This is a medical cart top pulled into a female or a pressure forming mold. We take a single sheet of material and we pull it into a tool, so this is your tool surface. We have the texture, we have the detail, and then these pockets are smooth. There is no texture in these pockets. This is a glove box for a truck. This goes in like that, so you want your detail here on the inside of this part. The outside doesn't look bad, but this is the non-tool surface of the part. This is an example of the secondary process we do. This is a sheet metal part that we have made. It's been stamped and then powder coated, and we're going to assemble this into one of our plastic assemblies. There's a vast number of products that can be made from thermoforming. Everything from heating and air conditioning drain pans to the fronts of ice machines to parts on trucks and buses and cars. We also get the question, what kind of tolerances can we hold in vacuum forming? Typically we can form 10 to 30 thousandths tolerances, and when we go to the CNC machine we can run much higher tolerances. Then the question comes up is, how thick can we thermoform a part? We go at C&K to 3/4 of an inch, 750 thousandths. At C&K, the process is simple. We mold it, we cut it, and then we ship it.
Thermoforming is lighter with lower cost